Welcome to the first part of a multi-part lesson in this module on structured data in Java, which will introduce you to arrays, which are a data structure that's common to many programming languages, including Java. After completing this lesson, you will recognize common array terminology, as well as know what a Java array is and how it works. You will also understand how to create an array and know the default value used to initialize all elements in an array. Finally, you will learn how to write a loop that accesses and processes all elements of an array quickly and efficiently. As discussed in the introductory lecture, we want to investigate the ability to store many different values in a single collection. In this lecture, we are going to explore Java's arrays. We are starting with arrays since they are the oldest and most common way to store a collection of values, and most programming languages support some form of arrays. An array is an object that can store a large collection of values for us as long as all the values are of the same type. And since all these values will be stored in contiguous locations in memory, the array has the ability to directly access any one value when given its position in the collection. This array object has only a small number of predefined methods. When first learning about arrays, it is easiest to think about them as a collection of variables that are all of the same type. And when we specify the position of any one element in the collection, we use zero-based indexing in the same way that the characters in a string object use zero-based indexing. That is, the first element is at index 0, the second at index 1, etc. For example, if we have an array called score that has 5 elements, it is easiest to think about it as a collection of 5 variables, score 0 through score 4. These 5 variables all contain data of the same type. We can use these 5 variables just like any other variable by accessing its current value, assigning it a new value, passing its value to a method, etc. Here is some common terminology that we use when discussing arrays. When addressing the entire collection of values, we talk about the array. And when discussing a single value in the collection, we use the term array element. The index is the position of an array element in the collection. The type being stored in the array is known as the base type. And finally, we refer to the number of values being stored in the array as its size or length. Since an array is an object type, we must declare its variable and create the object in a two-step process, which is similar to all objects except strings, since the compiler knows how to create those for us. The syntax of declaring an array requires that we specify the base type of the array followed by empty square brackets. The base type can be any type, including class types. The empty square brackets indicates that we want an array of that type rather than just one variable of that type. We then give the array a name. We then create the array object with a new operation where we specify the base type of the array again, and in this case we specify the desired size of the array in the square brackets. Once the array object is created, we can then assign it to the array variable. Here is an example. We see the declaration int square brackets score gets assigned new int 5. This creates an integer array object of 5 elements and assigns it to the integer array variable score. Note that score is simply declared as an integer array, and it can be assigned an integer array of any size. We only need to specify a size when we create the actual array object. The size is required and must be a non-negative integer value. It could be a compile time constant, or it could be a value determined at runtime. Once an array of a specified size has been created, its size cannot be changed. When an array is created, all elements of the array will be initialized to the 0 equivalent value for the base type of the array. That means arrays of type int and double are initialized to 0 values. Arrays of type boolean are initialized to the value false, and arrays of object type, including strings, are initialized to the special value null, which means there is no object yet. A common way to visualize an array is to draw a row or column of boxes and label each box with its index. The index of the first element is always 0. The index of the last element is always the size of the array minus 1. Note that square brackets are used in several different places and in different ways when dealing with arrays. First, we use empty square brackets with the base type when we declare an array variable. In that case, the square brackets are always empty. Next, we use square brackets with an integer expression when we create an array object. And finally, we use square brackets with an index to access an element of the array. When accessing an array element, we get the single element out of the array at the specified index. Again, arrays use zero-based indexing. If we reference the array element in an expression, we will get the current value that that array element is holding. If we specify the array element on the left-hand side of an assignment operator, we will give it a new value. We can use these array elements wherever we would use a normal scalar variable, as shown in the example code. First, we see how the array looks when it's created, and now we see what it looks like after the code executes. Score of 1 has the value 12, score of 2 has the value 15, and score of 4 has the value 3. The index that you use in an array reference must be an integer value in the range 0 up to the length of the array minus 1. If the index that you use is invalid, that is less than 0 or greater than or equal to the length of the array, then Java will throw an array out of bounds exception that will cause your app to stop. Here are several examples of valid array references and invalid array references. Note here how the index expression can be either a compile time constant or a runtime value, but it must be a valid index value. Given that we can now create an array, we often want to process all the elements of the array. The easiest way to do this is to use a for loop. In the example shown, we use a for loop to iterate over all possible valid indices and print each element of the array out on its own line. We can use the same for loop strategy to assign new values to all elements of an array. Array processing with for loops is easy since the array contains some number of elements, and for loops are good when the number of iterations is known. Now, there's one additional thing about arrays that makes processing them in for loops easy. Every array object has a data field called length that keeps track of the size of the array. Thus, you do not have to remember the size of the array. Rather, any array can tell you its size by accessing its length field. You can access the length field of any array by using dot notation on the array name. This is slightly different than accessing the length of a string, since for strings, length is a method that requires the parentheses, whereas for arrays, length is a data field and does not use parentheses. Note that this data field is read-only, and thus you cannot assign a new value to it. This makes sense, since we mentioned earlier in the lecture that once an array is created, its size is set and cannot be changed. This length field is very handy when writing for loops to process an array, as it results in cleaner code. Here's one of the for loops from a previous slide that prints out all the values from the array score. This loop has been changed to use the length field of the array rather than the literal 5. Note that this code will continue to work even if the program is changed in the future to use a larger or smaller array. The first part of this lesson introduced you to Java's arrays, which are a common data structure in most programming languages. Now that you have completed this part of the lesson, you should recognize common array terminology, as well as know what a Java array is and how it works. You should also understand how to create an array and know the default value used to initialize all the array elements. Finally, you should have learned how to write a loop that accesses and processes all elements of an array, regardless of how many elements it has.